Good evening, Algebra 2. Let's go ahead and delve a little bit deeper, into inverses of functions. Before we were doing inverses of relations, so they didn't necessarily have to be functions. Here they're going to have to. So we might have to do a little bit of a tricky couple things here in order to ensure that everything's a function. Properties of functions is 8.3. First thing you need to know, which I would absolutely write this down, is inverse functions theorems. So two functions, f and g, are inverse functions if and only if, for all x in the domain of f, if we take g composed with f of x, that is going to give us x every time. Remember what compositions are. That means take the function of x and put it into g. And also, for all x in the domain of g, if we take g and put it into f, we should get the result of x. So every time we should get x out. They don't even have to, or they obviously will have to match because they're both x. But even if they're like both 2 is what we get out of them, it's still not a function because the 2 is not x. We need x every time. I'll show you what I mean by this here in a second. And then notation for inverse functions, the inverse of f is f to the negative first power, which we kind of already talked about, but we're definitely going to be using more here in this next slide. So make sure you copy all this down. If you need to pause the video, go ahead. Okay, first example. It says are f and g inverses of each other. So this is where we get to kind of show, yes, they are, no, they're not, and we're going to use that theorem we just learned. Okay, so here we go. They give us f of x here is 1/3 of x minus 4, and g of x is 3x plus 4. So essentially I need to compose them both ways. So we'll just start out with f of g of x, which means take g, which is 3x plus 4, and put it into f here, where x is. So we have equals 1/3, and then 3x plus 4 minus 4. Okay, so essentially we need to see, does this all pan out to be x here? So I could keep copying this down, but I won't. I'm actually going to see if this all equals x here. So 1/3 times 3x is just going to be x. 1/3 plus 4, or times a positive 4, is a plus 4, plus 4/3, not 3/4. Okay, plus 4/3 minus 4, okay? So x plus 4/3 minus 4, all right, I don't think that's going to be x, because if I have 4/3 minus 4, if I change this guy into a fraction, that would be 12/3. So 4/3 minus 12/3, well, that would be negative 8/3. Well, x minus 8/3 is not equal to x. So therefore, we can stop here because our first composition resulted not with x. So we can stop. We don't even have to bother doing g of f of x because this one is not x. It's x minus 8/3, so we're done. So no, they're not inverses. So you would say no, not inverses here. Okay, so justify your answer. That would be that right there. Our first composition resulted not with an x. Okay? Alrighty, let's try this next one. F of x equals x to the 2/3, and g of x equals x to the 3/2. Okay, so let's try the composition. We'll first do f of g of x here. So we take g of x, which is this guy, and we plug it into f of x. So we have, in parentheses, x to the 3/2. And then, since we just plugged it in here, we still have this 2/3 power out here. Okay, well, remember your power rules. If we're taking a power to a power, we multiply. So 3/2 times 2/3, well, 3 times 2 is 6. 2 times 3 is 6. So we have 6 over 6, which we can write if we really want to. But 6 over 6 is really x to the first power, which is really just x. So here, we're good. All right, our first composition resulted with just x, which is what we want. So far we check out. But don't stop here, because not necessarily will it always work the other way around, so you have to make sure that you test that. We need to do g of f of x, which means we're going to take this stuff and plug it in over here. So we have x to the 2/3 now to the 3/2, which, guess what? 2 times 3 is still 6. 3 times 2 is still 6. We still have 6 over 6, which is equivalent to 1, which x to the first power is simply x. So since both of those check out, yes, it is, or they are inverses of each other. Yes, both compositions result in x. So therefore they are inverses of each other. Okay? Yay. Very exciting. Okay, so that's how you use that theorem. And that is anytime you're going to check to see if something's an inverse, you just do the compositions either way. And you should, if they are inverses, end up with x's as a result. If you don't, even after you do one and you don't get x, you can stop because it's not going to be an inverse. All right, let's take a look at example 2 here. It says let f of x, let f of x map onto x plus 500. Find a rule for f inverse here. So f inverse, now f of x, remember, this stuff is just y. And the arrow is really just an equals to sign. So don't let that trick you. This is really just y equals x plus 500. Yikes, super easy. Now we want to find f inverse. So what do? We switch x and y. So we say x now equals y plus 500. Well, this one's easy. To solve for y, we subtract 500 from both sides. So we get y equals x minus 500. Yay! Now, please don't box this up because we want to keep things in their proper notation. So since we started out in mapping notation, this is something we don't use very often, but let's make it look like that. Okay, so no more equals to. We replace that with an arrow, and then we can't have y, but we're going to have our inverse sign here. So we say the inverse of f, and then don't put parentheses, use your colon like you're supposed to here. So the inverse of f maps x onto, but now don't put this, because we found our new inverse function here is x minus 500. Okay, so f inverse maps x onto x minus 500. Alrighty, easy enough. These get a little more challenging depending on how complicated your equations are. X plus 500 is pretty simple, so it's pretty simple to find the inverse. Next theorem we need to learn about is your power function inverse theorem. And that says if f of x is x to the nth power, we just spent a whole chapter in power functions. And remember if this was squared, how did we undo it? We had 1/2 here. So g of x is x to the 1 over nth power. Remember, these could be anything. This could be 8 here and 8 here, 4 here, 4 here, 5 here, 5 here, etc. We already kind of can assume that these guys are inverses because they undo each other, and that's precisely what an inverse is. But anyway, let's keep going here. It says, and the domains of f and g are the set of non-negative real numbers, okay, which is very important that they're non-negative here. Real numbers, then f and g are inverse functions. And we're going to investigate why they have to be non-negative here in a second. Okay, make sure you get this guy down. Okay, they want us to prove it. They want us to prove that f of x being x to the nth power and g of x being x to the 1 over nth power, they want us to prove that they're inverses because that's what the theorem said. Okay, so how do we prove something's an inverse? Remember, we have to do two things. We have to find f of g of x and see if that's equal to x. And we also need to find g of f of x and see if that's equal to x. Okay, so this is actually, I know, proving. You're like, geometry proofs, oh my gosh, this is awful. Not quite as hard as you think it's going to be. We just need to find the compositions. All right, we're going to use that theorem here. So here we take g of x and put it into f of x. So we have x to the 1 over nth power to the nth power. And then again, remember when I take a power to a power, I multiply these powers. So if I have n over 1 here, this becomes x, and then 1 times n is n over n times 1, which is n. Well, n over n, oh my gosh, is x to the 1. It doesn't matter what these are. If they're one over the other, I can cancel, and it becomes 1. And x to the first power we know is just x, so far we're checking out. We're halfway there. Now we need to do the other composition, so we're going to take f of x and put it into this function over here. So we have f of x, which is x to the nth power, all to the 1 over nth power. Same thing though, this is over 1. So we say x, and then when we multiply fractions, we multiply the numerators, which n times 1 is n. We multiply the denominators, and 1 times n is n. So n over n, x to the first power, which again is x. So because these both turned out to be x, g and f are inverses of each other. So x to the nth power and x to the 1 over nth power are inverses. Okay? Now, remember, these are just your power functions. These would be like x cubed, and x to the 1/3 power would be inverses of each other. X to the 7th power and x to the 1/7 power. Okay, and I mean, these could be evens too, so let's say x to the 8th and x to the 1/8. Okay, all the same thing. They're going to be inverses of each other every single time. Now, these are the ones with stipulation, so let's check that out in the next slide. Okay. An instance of this theorem for n equaling 4 is shown. So essentially, an instance is just one case. So one case of this is shown, and that case happens to be when n is 4. So our two power functions are x to the 4th power, and then our inverse, this should say f of -1. So our inverse function is x to the 1/4 power. Okay? So as you can picture, now notice this is only the first quadrant. Alrighty? That's all we have here, because I know x to the 4th power is going to be a parabola, so it's going to look like this for its other half if we were to draw it in. Okay, when I reflect those in the line y equals x, well, if I reflected this piece down too, this would draw in the other half of the parabola, in which case, yikes, 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 is this guy a function anymore? Well, is he passing the vertical line test? No. So we can't have the other piece. So what we do is we say, all right, we're restricting ourselves. We're not allowed to have this anymore because we want all of these to be functions. Remember, the title of this was called Inverses of Functions, meaning we had to start out with a function, and then also its inverse has to be a function as well. All right. So if that doesn't happen, then we're not sitting pretty here. So we get rid of these parts, and we just do that so that we can work with these. All right. We get rid of those parts, and now if I just focus on these dark pieces here that are actually here, because we're limiting ourselves to the first quadrant, if I focus on these, both of these guys pass the vertical line test. So therefore, they are both functions, which is what we want them to be. Okay. So notice the graph only lies in the first quadrant. This is because the domain of the power function and its inverse is only the non-negative real numbers. Because if we had the negatives, remember there's negatives over here and negatives down here. If we had the negatives, we would result with not a function, which we cannot have here. It's kind of a sticky situation, and if you're still confused, don't worry, you can ask me about it tomorrow. But that's actually it for our inverses of functions. This is a lot like section 2, and I know those notes were long. So tonight you can kind of take a breather. Alrighty, I'll see you guys tomorrow.